Hello, this is Anthony Ingram Westover, and this is my version of Simacogo for AI CSC480. First of all, we'll go ahead and just do a quick playthrough of the game. So it starts out by asking you how many moves ahead the AI should look. This is specifically, so 1 would be the AI's next move, 2 would be the AI followed by the human. So we're going to go ahead and start out by looking 4 moves ahead to keep it relatively quick. Now you see the game starts. Start out with the current player is the human player, and the score is 0 to 0. The human can pick any one of the 9 columns to play in, and then the AI will determine what it believes the best move to be. And then this will just keep going as the AI will try and maximize the score for black minus white. So just play through a few of the moves. And as you can see, the AI tends to stay ahead of the human player, at least in this case. So going through looking at the code, this is just the start, the initialization code. Asks for the user how many moves the AI should look ahead, and then instantiates the game with that number. This one here represents the actual graphical elements. The board itself is a 10 by 9 grid, 9 by 9 labels where you store the pieces, and 1 by 9 buttons where the player determines which row or column to move into. So we have some more graphical methods to create the black and white pieces, the function that actually builds the board with the labels and the buttons, the function that goes through and calculates the actual score. This uses whatever player is the current player and calculates their score, checking to the right and then diagonally up to the right, diagonally up to the left, and directly above. So you only have to check 4 directions to get all the possible scores. Next we have the function that actually does the move. This here is just sort of a safety catch. If the AI for any reason tries to make an illegal move, instead of crashing, we'll just allow them to make a different move. Otherwise, if it's a legal move, we go through and we look at all the possible places, looking specifically for if we start at the top row and look at the row below it and say if that row has a piece in it, then we can place it in the row above. Otherwise, we keep looping down until we reach the bottommost row that does not have a piece. If we make it all the way to the bottom of the board, then we just drop the piece in the last row. Once we do that, we set the score, which just updates the labels at the top of the screen to display who's currently winning. And then so we switch the current player from player 1 to player 2, and if it is now player 2's turn, then we call the AI and ask it what's its best move and attempt to make that move. Finally, in the heart of the code, we have the actual AI code. This is all static code, so we just call it and say what's the best move for a given depth, and that's the number of plies we asked for at the beginning, and we pass in a 2-dimensional array to represent the current board. In order to do that, we percolate up the entire score list for the full tree. Once we have all the possible scores at the farthest depth, then we perform the minimax until we get down to our final 9 scores, which would be a score for each column. And then once we get to that point, we determine what the best score is, in this case the maximum score, for the computer to make, and the computer makes that move. For actually building the tree score, loop through, and if it's the final depth, so we start out at in this case 4 plies, and then we loop through until we get down to the bottommost ply, the 4th move, and then at that point, if it's legal, we mock the score and say what it is, otherwise we just have a placeholder. For the minimax, we do sort of the similar thing. We go through, we store all of the possible scores, and then check the alpha and beta to see if we can just ignore it. If we can't ignore it, then we determine if we're minimizing or maximizing, and change the alpha and beta respectively, and update what the best score is, and then store that and return it. We then have mock move and mock score, which just takes a current board and a potential move, determines what the board will look like, and then determines what the score of that move would be if that move were made. Thank you.